Let's take a look at our answers to our math map, please. As we take a look at number 1, how many inches are in a foot? How many inches are in a foot? 12. So we would have 12 inches minus 7 inches, leaving us with the 5 inches. Good. Number 2, how do we figure out the value of A? How do we figure out the value of A? Ooh, not 14 minus 82. 82 minus 14. And what did you come up with? 68, yeah. Number 3, when we have 216 and we divide it by 3, which one of those is the dividend? Which one is the dividend? And what is the 3 called? Divisor. And what is the 72 called? The quotient. Number 4, what digit is in the thousandth place? The thousandth place. And what do you mean by the third zero? Okay, all right. And number 5, what do we call the answer to a subtraction problem? The difference. And what was your difference? 1,200. I bet it wasn't, because there's a decimal point in there. You want to try it again? Okay. Eduardo? Very good. 12 and 62 hundredths. And number 6, we're multiplying 60 by 80. What do we call the answer? What do we call the answer to multiplication? You want to pass? Yeah. The product, and what was your product? What? 4,000? 4,000? Not quite? 4,800, yes. Number 7, the bought items went by multiples of what? 5. Therefore, go 5, 10, 15, 20, 25, then 30. The free items went by 2's, but it started with 1. So we added 2 every time. Therefore, the last 2 would be 9 and then 11. So if you buy 30 items, how many will you get for free? 11. 11. And number 8, your sum is? Your sum is? $10.32. Okay. And number 9, at what point do we know it is less than? At what point do we know it's less than, Peyton? At the thousandth place? No. The 10,000th place? And number 10, how do we find the perimeter of a square? How do we find the perimeter of a square? Ezra? More than that?
You can either do whatever the number is times 4, or you can, if you had an implication that one side is all three sides of the same.
So why would we multiply by 4? You said take one side and multiply it by 4. Why would we do that?
Because all sides are the same.
Okay. So if the measure of one side is 4, what is the perimeter of that particular square? 16. What would our label be? Anybody know what our label would be?
4. All of them will be 4.
Pardon?
All of them are going to be 4.
What would our label be after the 16? No?
16.
Ezra? No? Do we know that it's feet?
No,
Square foot.
Do we know that it's square feet?
Inches?
Do we know that it's inches?
What did you say?
No?
Square units.
It's not square units because it's perimeter, it would just be units. Units. Square would be if we were looking for area. It's just units, so 16 units. We don't know what the units are. They haven't told us if it's inches or feet or yards or miles or centimeters or meters or kilometers, okay? So because we don't know what the actual unit is, we just say units. So 16 units, 16 units, all right? Please get that recorded. Remember taking a look at the answers to your assignment. On 2 through 6, we're looking at the value of the underlying digit, the value. What's the value of the 3? The value of the 3?
there's only,
What is the value of the 3 is what I want you to tell me.
0 and
Just tell me what the value of the 3 is. What's it worth? 3/10. It's worth 3/10. Okay? Number 3, what's the value of the 4? The value of the 4. Piper?
4,000.
Not 4 thousandths. 4 thousandths would be clear over here. Oh, wait a minute. What did you say?
4,000.
Yes, I'm sorry. 4 thousandths, yes. I'm sorry. Hello. Number 4, what's the value of the 1? Sorry. I don't know what I was thinking of. 1/10, 1/10. Number 5. What's the value of the 6? The value of the 6, Lane?
1,000.
What?
It is 6,000.
6,000. 6,000. Number 6, what's the value of the 5? The value of the 5?
500.
500. 500. Questions on those? Sorry, Piper. I don't know where my head was. Clearly not on that problem. All right. Wow. Number 7, in words. We read the problem first. As though there were no decimal point involved. So we read it as 326. 326. And then we read the last place value, thousandths. So 326 thousandths. That should be your wording. 26 has a hyphen in it. Okay? Now, how do we write it in expanded form? 3 multiplied by 1/10 plus 2 multiplied by 100 plus 6 multiplied by 1,000. Okay? Questions on that? Make sure you're making corrections. Having parentheses around these helps separate it. You would not have to have parentheses. Number 8. the word and needs to be said at the decimal point. 8 and then we read this, 517 thousandths. 8 and 517 thousandths. The expanded form, 8 times 1 plus 5 times 1/10 plus 1 times 100 plus 7 times 1,000. Again, make sure you're making corrections. Questions on that one? Number 9, 924 thousandths. 924 thousandths. Notice I'm not saying 0 and. If there's just a 0 in front of the decimal point, we don't need to do the 0 and business. It's just 924 thousandths. 9 times 1/10 plus 2 times 100 plus 4 times 1,000. Questions on that one? Again, make sure you're making corrections. And number 10, 1 and 75 thousandths. Hyphen in that 75. 1 and 75 thousandths. One times 1 plus 7 times 100 plus 5 times 1,000. Questions on that? Anybody? Yes.
For one, couldn't we put 1 times 1 down?
What?
I was wondering if numbers instead of the 1, we would put 1 and 1.
1 times 1. Okay. We want to know what digit is in the hundredths place. What digit was in the hundredths place here?
It's the 8.
The 8. What's the number in word form? 306 thousandths. 306 thousandths. How many passengers can the train seat? There are 116 passengers. Each, if the train has 7 cars, and each car can, if each car can seat the 114 passengers, each should have been circled as your keyword. So 7 times, we can do that 114. Did you get 798 passengers?
Yes.
And number 4, what would we do first? What would we do first? Mallory?
9 plus 15.
So your next line would be 24 divided by 3 plus 2. What would we do first in that expression?
Divide into what I do.
So our next line would be 8 plus 2, which gives us 10. So you should have those steps as your work. Questions on that? Number 5, they have 15 stickers, gives 3 to a friend. The fact that we're giving some away would tell us to do what? She's getting 4 from another friend. Getting some would tell us that we are adding. What expression would match the words? We started with 15. We gave away 3, and then we are getting 4 more. So your expression would be that. All we want is the expression. Do we have an equal sign in there? Nope. Number 6, there are 138 people seated at the tables in a banquet hall. Each table can seat 12 people. All the tables are full except for one. How many full tables are there? We have 138 for our total. 12 at each. 12 goes into 13 one time, into 18 one time. We get a remainder of 6. We want to know how many full tables there are. How many tables are full, Eduardo? 11 tables are full. How many tables would we need to seat everyone? How many tables would we need to seat everyone? 12. How many people are at the table that is not full? 6. Questions? Anybody? All right. Let's get our number tiles out, please. And do you still have the paper that looks like this? Let's get it out, please. All right. Today we are going to compare decimals. And in comparing decimals, we have to know our place values. And we've worked with place values all year long. We keep asking questions about place values. Every math minute, I think we've had place value questions, it seems like to me. When we work with decimals, yes, ma'am. You don't have one of those? All right. So when we work with these, we have to be able to, first off, put a correct number down, and we have to be able to look at our place values and be able to compare our numbers place value by place value. All right? So when we use our papers that you have in front of us, that's what we're going to be doing, is comparing our place values by place values. So as we take a look at this, first we're just going to practice, can you put numbers down correctly? So I'm going to give you some numbers, put them down with your number tiles, and then we'll move forward from that. Here we go. 6 and 45,000. 6 and 45,000. 6 and 45,000. 6 and 45,000. Then you'll have to get a piece of paper and tear off some. Did you find your 7? Anybody else who doesn't have one of these papers? Anybody? Okay, the first number you should have built should have looked like this. Okay? All right. 18 and 400. 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 Okay, so it should have looked like this. All right. So when we look at these two numbers, if we wanted to compare them, the easiest way to compare them is to line up your decimal points. Okay? And when you line up your decimal points, you can easily compare place values to each other. You will notice on our math minutes, every time we are comparing them, I don't just say, hey, was it greater than or less than or equal to? Have you noticed that? No. In fact, I always give the answer and I say, hey, at what point did you know it was such and such? Okay? That's because when you're comparing, you should go by place values. So in this case, if we look at our tens place, we already know that 110 is greater than no 10. So we already know that this one is going to be larger. Okay? Does that make sense? Questions on that? All right. Let's turn our books then to page 163, please. And as we look on page 163 and we start comparing When we line up our decimal points, we can easily compare our place values, like place values. So we're comparing 2 and 495 thousandths to 2 and 493 thousandths. Our ones are the same. Those are equal, our tenths are equal, our hundredths are equal. When we get clear over to the thousandths, 5 thousandths is greater than 3 thousandths. So at that point, we know 5 thousandths is greater than 3 thousandths. So therefore, we know that this is our larger number. Does that make sense? Okay? Up until that point, everything was equal. Does that make sense? Okay? Questions on that? So as we take a look at the next one, we have three numbers that we are comparing. We line up our decimal points. The ones are all equal because there's a 2 in all of the ones places. The ones are all equal. There's 7 tenths. And now we look at the hundredths place. The 2 is the smallest. So this is the smallest. The 3 would come second, and the 4 would come last. Okay? So if we're putting them in order from least to greatest, we have to go out to the hundredths place in order to get our order from least to greatest. Okay? So who has the least height? Who has the greatest height? Okay. So as we take a look at this, we've got to put these in order from greatest to least. They put the first number in the table. We can put the second one in the table. The third one. And the fourth one. Well, if there's nothing here, what digit would go there? This time it went from greatest to least. Our ones in the ones place are all equal. We look at the tenths. Our 4 is greater than the 3, so we know that's going to be the largest. So we can take it out and put it as the largest. The 3s are all the same in the tenths now. We look at our hundredths. In our hundredths, the 8 now is the largest compared to the others. So now we're done with that one. And now we move on to the thousandths. We have a 1, we have a 0 or nothing, right?
Yeah.
Okay. The 1 is definitely bigger than nothing, so that would be our next one. Leaving us with 1 and 32 hundredths as our smallest. Questions on that? Any question on how to line these up and eliminate going from largest to smallest? Eduardo? All what numbers? From this list? They came from that list. Okay? that answer your question? Okay. Anything else? All right. All right. These directions would just say name the greatest place value position where the digits differ. That's no more than the question I've been asking all year. At what point did we know there was a difference? So we take a look at number 5. At what point do we notice there's a difference? Jonathan?
At least, in the hundred.
Hundredths? So when I look at the hundredths place, which number is going to be greater? 3 and 579 thousandths or 3 and 564 thousandths?
3 and 579,000.
So that's what those directions are asking for. Does that make sense? Questions on that? Eduardo? The 3s were the same, the 5s were the same, the 7 and the 6 are not, and they're in the hundredths place. Does that help you? Okay. Least to greatest. I'm going to want you to line them up. Notice, is there enough room on this page for you to do that? No, so you're going to need another sheet of paper. Does that make sense? Okay. Comparing, I'm going to want you to line them up. Is there enough room on this paper for that? No. Okay. Does that make sense? So you're going to use this process again for comparing and being able to put them in order. Questions? Anybody? All right. Let's take a look then on page 167. On 167, we're going to do the evens. That would be 2, 4, 6, 8, 10, 12, all the way down to and including 14. Does that make sense? I'm not circling all of them. Okay? Does that make sense? So 2 through 14, the evens. We're clear on that? We're going to show work on another sheet of paper. Are you clear on that? Yes. Tomorrow. And that's it. Okay? Questions? Okay, get busy. Oh, really? Show work on line paper. Did I show you what all I wanted to be shown? Uh-huh. And where have you shown it? Absolutely line paper. Okay. What work are we supposed to be showing? Lining up your decimal points and comparing place value to place value. Did I not show you that already today? I was pretty sure I did.